So I have been informed by your monitor that probably many of you have not received yet the um, the document for studying the course. So please check in the LMS system because I already uploaded the chapter one in on LMS, and if there is no problem, I believe that you can download the documents so for your self-study at home. But if it's not possible, just let me know. Okay, I will send the file to your monitor when the class finishes, and then yeah, your monitor please share with your own the members of your class. So no problem. Yeah, system. I'm not sure whether this is the Vietnamese system or we have bought the license from another countries in the world. Then the quality need to be checked. Yeah, because I the procedure is that I have to open the MS system before I turn on the Google Meet. In the meantime, I can use Google Meet without opening the LMS. So I just try to follow the instruction of the institute academy, and then. But okay, now I know about the this, so I will pay attention. So in the next time, I will share with your main monitor, and then the monitor will be responsible for delivering the document to the remaining members of your class. Okay, so you can be sure. So let's continue with our discussion on the step of additive manufacturing, and we stop at Mallet at the building process. And I have mentioned to you that is an automated process. Okay, just push the buttons or give the command here run or start the process, and then the system can automatically handle the work. Monitoring may be needed, yeah, in some case, especially in the case of power outage or if the material run out of. Yes, and then this is the case that you need to interfere to the process in order to fix the issue regarding the electricity and the refill the material feedstock, for example. Yeah, or maybe the software. Yeah, yeah, nobody knows in advance, but there may be the unexpected case that may occur during the bidding process, and for sure the technician has been trained, trained in order to solve the issue when an error occur, and you can troubleshoot this situation, troubleshoot this thing. Remove. Yes, of course. Once the build is complete and part need to be removed, but be careful. Yeah, I have reminded you that about these remove and post processing steps. Because in some case you need to release the stress inside the building chamber. So in that case, after the 3D printing process, you how can I say, suck on of the remaining powders from the building chamber firstly, and then you apply the heat treatment process in order to release the residual stress. Or you may want to apply some kind of heat treatment in order to improve mechanical properties of the part. And afterward, yeah, you might be interested in removing the part from the building chamber and from the support structure and from the building plate. Yes. And the post-processing, yeah, will contain several steps, sub-steps. So, for example, cleaning, removing support, yeah, heat treatment. Yes, because you already remove it from the building plate. So this is a little bit tricky because there are two things. If you perform the stress releasing process, and then this will be done directly after the building process. But if you already remove it from the building plate and support structure, and you bring it to the other oven or the other furnaces, and then you can perform another heat treatment during the post process. Because the heat treatment doesn't only mean that stress releasing process. No, stress release is just one of the steps that can be performed, and it belongs to the group of heat treatment. So using the heat in order to treat the material. Yeah. So in the building chamber, it simply means that you apply the heat treatment in order to release the stress. But once you have removed the part from the building chamber, from the support, from the building plate, yeah, and then you bring the part to the another furnace, cái lò lò để nung kim loại ạ, or oven cũng là một dạng lò, đúng không ạ? Thì trong trường hợp đó nó sẽ không phải là khử ứng xuất dư nữa, mà nó là còn các cái dạng, đúng không ạ, gia công nhiệt để tạo cho chi tiết có cơ tính phù hợp, thì cái đó là trường hợp khác. Còn khử ứng xuất dư thì người ta có thể tiến hành được ngay ở tại cái building chamber, đúng không ạ? Trước khi mà chúng ta đưa nó ra khỏi cái building chamber đó, chúng ta thực hiện ngay khử ứng xuất dư. Khử xong rồi chúng ta mới bắt đầu bỏ các cái support structure, bắt đầu cắt cái part nó ra khỏi cái building plate. Rồi sau đó các bạn muốn tiếp tục các cái loại ủ khác, hoặc tiến hành tôi các loại thép chẳng hạn, rồi ram thép, rồi làm thấm carbon hoặc là làm thấm nitơ chẳng hạn, vân vân, thì tất cả những cái đấy là heat treatment khác chúng ta có thể apply. Và một dạng heat treatment nữa thì nó cũng không đơn thuần, nó gọi là thermomechanical treatment, có nghĩa là cả cơ cả nhiệt. Thì ví dụ như là hot isostatic pressing chẳng hạn, thì cái biện pháp đó cũng có thể được thực hiện trong cái quá trình post processing để nâng cao cơ tính, đúng không ạ, của cái chi tiết mà chế tạo bằng phương pháp in 3D. Or other post processing step may be needed. Yeah. Application. In many cases, part can be ready to be used. Yeah. In other cases, the part may be required to be painted or other kind of treatment. Like painting is one type of coating, yeah, with the paint, yeah, and may require to be examined with another component to form a product. Yeah, that's right. So if you print out the gear, so you need to examine the gear with another gear, yes, to transfer the motion or the torque between the two shafts. Yeah. So this is noted here that the AM machines require careful maintenance because this is some kind of mechatronic system. Yeah, mechatronic system, and there are several AM material are not now standardized. Yeah, because it's under development, so that's why it's not yet fully understand. People need to do some kind of research in order to understand these material better before they can be standardized by several kind of organization like ASTM, American Society of Testing Material, or the ISO, ISO International Standard Organization, to standardize material. So because it's under development, these are under development, and therefore many AM additive manufacturing material are not yet standardized. So we need more knowledge about them. And some raw material used for additive manufacturing may require careful handling. For example, I'm pretty sure that you know about the aluminum. Yeah, aluminum in general, in the form of billet or in the form of the cell phone. Let's say the cover of the cell phone is fine. But if aluminum is in the form of powders, extremely small powders, micron size, for example, and it's easy to react with water, and it's easy to be burned out. If you have just electrical discharge or cái tích điện and occur, and it exposed to the aluminum powders, and the explosion, no, well, can occur. So this is one of the issue that you need to pay seriously attention, to pay special attention to this kind of material, and especially when handling the aluminum powders, because it's quite dangerous. The other thing is that the metal powders is quite detrimental to human health. It's quite it's not healthy when you breathe, and you breathe, yeah. And if the flow of air contains some kind of fine powders, and it will be stuck, the powders will be stuck in your lung, yeah. And let's image what happened with the health of the people who do that. It's quite detrimental. So, and now you have heard a lot about the PM 2.5. This means that the powder metallurgy with the grain size, with the powder size of 2.5 microns. So it's quite fine powders. So if people have breathed this kind of powder into and get into and bring it into your lung, and you will have serious consequence regarding your health. Okay. So some raw material used for additive manufacturing may require careful handling. In general, for powders material and powder metal in specifically, you need to treat it carefully. You need to treat the material carefully. Otherwise, bring back a lot of negative things to, to us. Okay. Advantages and challenges of using AM. Yeah, there's a lot of advantages, but usually they come along with the challenges. Okay, let's analyze a little bit in detail about advantages and challenges when you try to bring the AM into industry, especially aerospace industry, for example. Small batches of customized product. Yeah. Yes, because usually if you have the production line, yes, in a big manufacturing companies, so you can fabricate, for example, 100,000 parts, let's say per quarter, 3 months. But for with using the additive machines, you can just print out, let's say, less than 100 parts per each time you print out. And for the last side part printed by the machine with more building chambers, and even you can print out just one part per one time printing. And therefore this is said here that this just is suitable for small batches or small production. Why is had advantage? Because it's not designed for mass production. So if you have the mass production line and fabricate one part solely, and the cost of this part will be extremely high, so it's quite expensive. But if you use the AM printer, you print out one part, and it's okay. The price will be reasonable. Yeah. So This is designed for small batch, so this can be considered as one of the advantages of using AM. Directly production from the 3D CAD model. Yes, and we have talked about the thing that additive manufacturing can be used in order to manufacture the near net shape part. Yeah, and the building process is just an automated process. You just need to push the button, and then you have the almost final part with the near net shape, and in some case for visualization. So we can fabricate the final part with no additional tool or mold. Yes. So you reduce the number of manufacturing steps, meaning that you reduce the cost of contribute account for by the or let's say you reduce the cost, yeah, resulting from this process which is not present here. So for example, if you print out the gear will have the shape almost approach the final shape of this gear. Yeah. So just for viewing, yeah, to see, yeah, just for viewing. So there's no additional tool applied. So you may not need to cut, or you may not need to polish, and you do not need the mold, to shape the part. And the costs associated with the cutting process, the costs associated with the molding process are not present here. In other words, you save the cost because you apply only one process, printing process only, to have the part. And comparing to the traditional manufacturing process, first you need to cast, you need to melt the material, you need to cast, yeah, to have the billet, you have to force, to shape by using the hammer, for example. Yes, and then you put them into the cutting machines, to cut, yeah, to reach almost final dimension, and then you need to apply other process, threading, and so on. And each will contribute to the cost, to the final cost of the part. The how can I say? The more manufacturing step you need to apply to fabricate the part, the more expensive the part is. And now with the additive manufacturing, you can reduce the number of steps for fabricating the parts, and then the cost can be reduced. The cost can be reduced. And this is another advantages. Design in the form of digital file can be easily shared and facilitating the modification, customization of components and products. Yes, for sure. Because this technology is issued in the industrial revolution, fourth industrial revolution, and everything is somehow related to the how can I say, uh, internet. Let's say I uh, I do not find an appropriate word at the moment, but somehow relating to the internet. So the design can be performed digitally. The part, the design part can be stored digitally in cloud system. In cloud, you can easily discuss the result with your customers, and your customer can see your design. The customer can see how the part perform virtually after you perform the FE analysis, for example. Yes, and the customer can contribute to improve properties of this part by giving you some kind of suggestion in order to improve the geometrical design of the part, so that you can implement some kind of design, some kind of features, yeah, to improve this performance. And this can be done virtually without creating the real part. So you save a lot of cost for fabricating the real part during the development phase, just the development. Yeah, and it's better than the traditional process of product development, because you need to fabricate the part, you need to test the parts, and if the parts cannot satisfy the working condition, and then you have to throw them away. So it wastes cost time. Yeah. And the fork of the engineers. Yeah. And customization is somehow possible to customize the product. Some modification can be applied to modify the structures of the components of product. And as I already mentioned to you, now we are in the future or near future, we tend to, how can I say, follow an approach of creating the digital warehouse instead of physical warehouse. Because if you build up the physical warehouse, so you have to invest a lot of money, and then you have to store the part, and basically the quality of the parts reduce as a function of time because the oxidation process, the humidities inside the storage area will have the negative influence on the quality of the part, and so on. And therefore, if you store the part for a long time, yes, the quality of the part and even the values of the part will be reduced to a certain extent. Yeah, but it will be reduced. And therefore, people think of the now is the era of digitalization. Yeah, why don't we create the digital warehouse? Yeah, on cloud, for example. And once we need the design, yes, of course, we must have the license in order to accept this kind of database. You need the license. You have to pay the money. Yeah, uh, and download the design, implement the features which may be need for the structure or which come from the requirement of the customer. Yeah, you check the performance, and once everything is okay, and then you import this kind of modified model to the printer at the site where you need to sell the parts. Yeah, so it's offer not only the on-demand manufacturing but on-site manufacturing as well. So you save the money for investing the physical warehouse to building up the building in order to store the spare parts. Yeah, it has the many benefits to the for example, manufacturing companies. So it changed the way of logistics. Yeah. Yeah. So now, for example, in Norway, uh, the concept is that they have fabricate the no, they have how can I say, manufactures the system inside a container. So they bring the container with 3D printer and material to the place where they need to fabricate the part, and it's stored there. And it is there. For example, the oil platform, because the oil platform is far from the shore, far from the how can I say, mainland, let's say. And if you, for example, if you need to buy the part from the mainland, you need to use, for example, the helicopter in order to ship the part to the oil platform in the middle of the ocean, for example. So it's not, how can you say, it's not reasonable because it's costly. Or you can wait for several months by using the boat or ship, to ship your part to the oil platform. And the whole system is blocked because one or several parts has been broken down. So do you think about that? And therefore, if you do not want to suspend the whole system, you need to change or replace the spare part as soon as possible. So one of the approach, another approach is to have the 3D printer system on site. So whenever you need, just access the database, download the model, modify the model appropriately, print out the part, and replace. So design the form, this is the file, easily share. Yes, it means that we can share. We upload to the cloud, to the database, you can share, you can modify, you can customize, whatever you want. to satisfy your needs. And the additive nature of the process gives material saving. Yeah, for sure, because we produce the near net shape parts. As that the ability to reuse waste materials. Yes, but be careful about the reuse waste material. Yes, is one of the things. Now, because the point is that, for example, if you print out the metal parts by using direct metal laser sintering, okay, let temporary do not focus on the name direct metal laser sintering or something like this. Is one of the technologies belong to the additive manufacturing. But the thing is that when you print out the metallic materials, you need the high heat source. You need the laser in order to melt the material. You need the electron beam, for example, to melt the material. It's the high energy, and it's create the heat. The heat is used to melt the materials, but it affects also the surrounding region because the heat can dissipate or transfer to the surrounding environment. So if the powders is in the region that the laser scan through, and if the heat is enough, the material can be melted to form a molten material and and the material solidify and connect with the adjacent material and the previous layer. But the problem is that the heat transferred to the surrounding powder and it's modify the properties of the surrounding powders and normally reduce the strength of the powder and may modify the composition of the powder as well if the heat is enough, is large enough, if the heat is strong enough. And if the heat modifies the property of the powders negatively, and then if you reuse this kind of powders for the next printing process, and then the properties of the printed parts will have some kind of issue. Yeah, and there's many methods in order to check the quality of the parts. So we cannot hide the customer about that. So if the customer require high quality parts after the 3D printing process, so for sure these powders cannot be reused. But from the how can I say, economic point of view, from economic point of view, yes, uh, reusing this kind of powder is reasonable because it saves costs. Yeah. But cost and quality. Don't ask why. Don't ask the parts with high kiss qualities if the price of the part is not expensive. Let's say, yeah. They, how can I say, they are directly proportional. High quality, high price. So if you buy something which have a low price and yeah, if there is some kind of sale off, yeah, and it's okay. But if not within this period, and then you have bought something which have low price, and you may suspect about the quality of the part. Yes. And the estimated 95-98% recyclability for metal parts. Yeah, recycle. Recycle but not reuse. Reuse may have problem, but recycle is okay. Novel and complex structures. Yes, for sure, because there's almost no limitation associated with the how complex the structure is. So no matter what the structure is complex, and by using additive manufacturing, and you can print out the part. So even if you have some kind of complex internal volumes, um, this can also be fabricated by using additive manufacturing technologies like internal cooling channel, mm, or lattice structures inside the what can I say, the cover, some kind of cover. But, probably in the next few slides, I will show you about the lattice structure, about the complex internal cooling channel, and so on, and so on. Where's my bottle of water? Final part, having low porosity. Mm, mm, mm. It depends on the technology that you use, because for the moment, the yeah, there are several AM technologies can fabricate the part with 100% relative density, which means that completely solid materials. But let's say several years ago, the highest density that the AM part can reach is 99.95%. So there is 0.05% porosity, so free volume inside the parts. And design with larger amount of voids will have high stress concentration, and during the working condition of the part, yeah, the crack can occur there. It's crack initiation site. But I'm not sure whether the advantages regarding the final pass have a low porosity is 100% correct here, but it's okay. It is okay. Making to order reduce inventory risk. Yes, inventory risk. Yeah. For example, if you build up the physical storage, yeah, or physical warehouse, and then to may have some kind of risk, because if you invest money, if it brings some kind of benefit to you, it's good. But if not, then you have some risk regarding the investment. So in the case of additive manufacturing, you know that you can follow the approach of on-site and on-demand manufacturing. So there's no need of building up the kind of storage. There's no need to store the spare parts. And whenever you need to print out the part, and that's good. And it reduces the cost and reduce the risk of investment. Distribution allow direct interaction between local consumer, client. Yes, yes. And now, like you and me, we discussing the lectures via Google Meet, and by using internet, yes, we can easily contact, discuss, distribute the design model uh, between local consumer, client, no matter what, no matter where you are. Yeah, I can be here, I can be in another country, and I still have the ability in order to contact you to discuss about the lectures. So in the real situation, there's possibility to distribute, yeah, or direct interaction between the customer or or the company, those provide the service, yeah, and producer, yeah, without the presence of obstacle, let's say. But of course, everything has two side effects. The using of AM has certain advantages like this. Uh, Probably at the end of this chapter, you will be familiar with more sustainability advantage and challenge of AM. So this combined with a sustainability term. But now, just some some main advantages of Asian AM. But going along with advantages for sure. Everything has the have the challenge, or yeah, uh, probably the author of this journal did not want to mention about the disadvantages, and therefore they use the word challenges. The cost, because it's relative new technologies, relative news. This has been developed since 1990. Okay. But it is it has significantly developed in recent years. Anyway, it's relatively new, and the cost for the machines and material is still are still high, and for the cost for the process and for the part is relatively expensive, especially for metallic parts. Yeah, and previously in 2018, my group have print our how can I say have order actually to print out several kinds of aluminum silicon 10 magnesium fans, which used to control the flow of hydrogen inside the hydrogen powered car. And for each one with with the dimension of, let's say, 10 centimeter, 10 10 and 9 centimeters, and each one costs around 2,000 euro. So at that time it's quite expensive, and I do not check it now. And the speed of production, because you know that it's suitable for small batch production, so it means that for several products is suitable, but for mass production, then the use of additive manufacturing is not suitable. So low speed of production, let's say. Because please remember that you have to set up the motor, you have to print out, you have to apply several steps regarding the post processing, and so on. And yeah, but I would say that it is a general comment. It, we must examine in detail. For some, yeah, low speed production, and for the other is quite speedy. That is why we call rapid prototyping. Yeah, we call rapid prototyping. So it depends on the situation. And please remember that if you have a production line which can be used to fabricate, for example, 100,000 parts per month, and if how can I say, R&D, research and development department of your company in the future, for example, required to fabricate the part during the development phase, think of the fact that can you stop the production line in order to fabricate just 10 parts just to check if your design is okay or not? And I would say that no, it's not possible. Why? You have to stop the whole production line just to fabricate 10 parts, and 10 parts is just for checking. It's not for selling your customer. No, and that is not reasonable. And in that case, the additive manufacturing process can be used in order to fabricate the 10 parts at a reasonable cost, and you do not need to stop the whole production lines for the developing the parts. So this is the idea. That's why we need. Oh, okay. Changing the way of design to think about and approach. Yeah, yes. Like the horse run on the road. So if the horse is familiar with the road, and he or she try to run on the same road for the next time, so it's quite difficult in order to change the mind. Do you get the point? So the designer or the engineer familiar with the traditional designing process. So now if you ask them in order to apply the new approach in designing process, mhm, For some, they are willing to change, but for the others, they may not. Removing the perception that AM is only for rapid prototyping. Yeah, so it's okay. Let's keep this point. Development of standardized of new material, and as I already mentioned to you, that it depends because we are now developing. So many researchers in the world, or many companies have been developing these new materials for additive manufacturing. And since these materials are under the development phase, so they are not yet standardized. So if you work with something we are not standardized, so you have something of risk associated with the materials. So the properties cannot be warranted, even if you refer to the how can I say the working experience of the previous researcher, but nobody guarantees that there's no no error occurs. Validation of material, mechanical and thermal properties of existing materials and AM technologies. Yeah. Yes, the validation. Validation is almost the final step, during the product development phase. After the verification, and you need to validate your design. Then is one of the challenges for AM because the material and the part made of AM are not yet standardized, so the validation has for sure challenge. Yes, development of multi-material and multi-color system is not only the problem with AM but also for the others. Yes, how to combine them together, and using dissimilar material in one system may create how can I say a battery which promote corrosion. So it's not easy. So you might have some kind of techniques in order to protect the anode material because once the battery is formed, and then the anode material tend to be corroded, and therefore, yes, on Tuesday I have mentioned about the sacrifice anode. It means that another type of anode will be introduced there, and this introduced anode will be corroded instead of the original anode or cathode anode. Automation of AM system and process planning to improve manufacturing efficiencies. Yeah. So, yeah, the higher degree of automation system, and yeah, probably the higher degree of automation system, AM system can reduce the amount of work for human. Yeah, for laborers, because and process planning to improve manufacturing efficiency. Yeah, it's a challenge. Yeah, post processing is often required. Yeah, I would like to skip this point because you have not studied about the stepping effect. Just the thing is that when you select a large or thick layer when printing out the part, and then one layer on top of the other tend to, what can I say, create the step or the stair. Yeah, the stair, and it's reduced the surface uh, finishing quality. And for sure, you need to add more material during the printing process. And afterward, you just need to cut the most outer layer after the 3D printing process, and then you can improve the surface quality of the part. Support material cannot be recycled. I would say that it cannot be reused, yeah, but can be recycled because you just you just need to take the cut the support structure out of the part, and and a building plate, and then you put them into the furnace, melt them together, and then you can reuse water optimization and can fabricate the powders material again. But that is quite difficult thing in order to minimize the support structures for a good view of orientation. For a good view of orientation, because usually you need to find a trade-off between the three parameters, including the building time, the distortion of the part, and the amount of support structure. And once you minimize one parameters, and the other tend to be increased, and you need to find the balance. Intellectual properties regarding the copyrights, yeah, for sure, because everything is stored online, in cloud, for example. And then once you download the design from the database, and then you must think about who was who is the designer who create that model, and you must pay the money to the one who designed that. So it cannot be obtained freely from the cloud. So for sure, how to manage, how to administrate that is a challenge for the moment, but for sure in the near future people have developed the rule or regulation for the for using the digital warehouse. Yeah, let's say. And I would say that the designer and engineer need to have a high skill in using additive manufacturing system, because when handling the material, I have talked to you that when you work with the metallic powders, so it's quite detrimental to human health. So uh, technicians or engineers need to be well trained about how to handle the powders and how to use appropriately the additive manufacturing system. Yes, to avoid any kind of how can I say trouble may happen during the operational phase of the machines. Yeah, and continuously changing set competitors. Of course, there's actually for the moment there's many companies who they have developed the machines, the AM additive manufacturing machines. So, for example, in Germany, they have the SLM system, selective laser melting system in Lübeck. They also have a company in in Munich, on the EOS, so which have also developed the additive manufacturing system, or DMG Mori, yes, which also originated from the Germany. Yes. Like in Norway, they also have a patent technologies called rapid plasma deposition, which used to fabricate speedily the titanium part. Yeah, titanium part. And yeah, okay. Just some points about reverse engineering technology. Yes. So the idea is that when your motor is too complicated to design, we are using the computer-aided design software. And why don't we use the how can I say shaping? Why don't we shape the clay part, for example, by hand? Because we just need the external shape of the part, and afterward you use the 3D scanner system in order to scan the external shape and to generate the point cloud. And by using the appropriate software, you can example the point cloud and generate the faces model. Yeah, you connect the point and you certain algorithm in order to generate the model. And this we pay attention to the surface model because we need the STL file. because the SDL file is compatible with the additive manufacturing machines. And but the problem is that if you have one time to play with the 3D scanner, I have several times, and you can have a lot of defect there because practically you scan. You cannot scan the whole part, the whole complex part at one time. So you scan a part of this specimen, of this a part of this part, yeah, một phần của cái part đó, part of this part, and then there will be a referring point, and then by using a certain software, for example, the mesh lab, you can combine them together to have the motor after the 3D scanning. Yeah, for sure. Now there's several kinds of systems that can help you to generate the scan motor automatically, like LumaFilm, but for sure it's more expensive than the general 3D scanner. But I just would like to highlight that it's not easy to perform. Yes. You can have some kind of problem during the 3D scanning. So you need to adhere the fixtures. You need to scan one part, but when you scan the part and the example part as well. And yeah, the fixture. So you need to play, you need to modify the motor after 3D scanning in order to generate the so-called SDL motor, which can be used. And please remember about the waterproof motor. Yeah, the object can be scanned using the laser scanning method or the torch probe technologies. And CT scanner, I think that you may be familiar with this kind of term, but is mainly used for the what can I say, a medical section, a medical segment, or let's say medical area. So to be more precise, chụp cắt lớp. So yeah, so scanning using software, draw different layers, yeah, identify the surface boundary and so on. Yes, but it's expensive. So basically, is to capture the geometry, to digitize the object, yeah, turn to capture the geometric features of the real object, and to generate the digital motor. But this is the destructive-based approach for capturing geometry. Yeah, because you need to cut and scan, cut, scan, cut, scan. But it will not be the case of CT scanner for sure. It will not be the case of CT scanner. NAM is a technology can be used to reproduce the scanned part, because it's simply, no matter what the design process is, you just need the SDL motor and you can print out the parts. Yeah. And if the motor is fabricated or is generated by a scanning procedure, NAM can print as soon as you have the SDL motor. That's all. Okay. Okay, let's say we have 10 minutes break, and see you again at 2:05. And please remember that from 2:30 and 3, please write out your name on the let's say machine sections, and please do not typing. Please do not type the how can I say some story inside on the message, because this place, this is just the place for you to write your name for checking attendance. In between 2:30 and 3. Before that, you can write down. If you have some kind of question, yeah, or if you want to discuss with me or with your friend, no problem. But in between 2 and 3, yeah, please remember that. Thank you. LiDAR sensor on iPhone product can send 3D. I don't have chance to test. Yes, but the problem is that after scanning, you have what? And what you need to do with this scanned motor. And whether or not you scan the external shape or you scan both the external shape and the internal features of this part. This is the point. This is not easy because now I just mentioned to you about the, for example, the clay pot. Yeah, with the shapes manually by hand, and then you scan to have the external model. And when printing out, you can print the surface, or you can print completely solid based on the scan geometry feature. But let's think that if apart from the external shape, you have the internal features, and you need also to scan the internal feature and think about that. Then that is the point. That at the moment, a company called Lumafil, they use the X-ray in order to scan. They scan both the external skin and the internal feature of the part. Yeah. I think it says just scan external model. Yes, okay. So you can try. You scan, and then you import it into the software called MATLAB or the other kind of 3D, the software that can, how can I say, modify the model and prepare the model for 3D printing, like Autodesk, NetFab. This is free for students. You just need to create the Autodesk account, and then you, yeah, the educational license is free. And you can have the premium license to play with the scanning model in the form of STL file, and then you can easily modify the STL file. To repair the STL file as well, because somehow you need some kind of defect, and you need to fix to repair this kind of defect, and then and this can be done with NetFab. NetFab. Okay, I can write down here. NetFab. Okay, we on yes. And you can download and try to use NetFab. Yes, and there's many tutorials online on YouTube, and you can see and play with this. It's quite good. And I just like to let you know that in Vietnam, there's several companies working in the field of additive manufacturing. So it's not something we talk for fun. No. There's certain companies in Vietnam, they work with additive manufacturing to fabricate the parts. It's not something in theory, but they work practically. Okay. So. Okay. See you later.